So here's another example with derivative functions. Big f of x is 1 divided by x minus 2, and we want to find f prime to 0, f prime to 12, f prime to negative 8. So as we mentioned in the last video, we don't have to do this 3 times over and over. All right? We only have to do it once with just x, and then we can just plug these numbers 0, 12, and negative 8. We can just plug them in to the derivative function. So let's go ahead and find the derivative function. Big ol' f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all divided by h. So I want to point out that even though we're doing derivative function now with x's instead of numbers, nothing changes. Okay, the process is all still going to be the same. It might be a little bit messier algebraically, but the interpretations are still the same. Derivative is still slope. Always remember that derivative is slope. Okay, so it's still going to give us the slope of the tangent line, slope of the curve at that point, etc., etc. It's also the instantaneous rate of change still. None of those interpretations have changed. Okay, the only difference is now we're just using x instead of a number, just to make things simpler towards the end. Okay, so now we just got to figure out what is f of x plus h, and we're already given f of x, so we don't have to worry about this. But let's just figure out what's f of x plus h. So f of x, is 1 over x minus 2. So f of x plus h is 1 over x plus h minus 2. And that's actually, it can't be simplified much more than that. So this is f of x plus h, so let's go ahead and stick this into here. So this equals the limit as h goes to 0 of 1 over x plus h minus 2. And then we have minus f of x, which is 1 over x minus 2. Okay? And then on the bottom we just have h. So what do we have here? We just have rational functions, right? So again, we could do a common denominator thing by ignoring this h down here, get a LCD, least common denominator here. Or we could just look, here's x plus h minus 2, here's x minus 2. So let's multiply the big top and the big bottom by this and this. So we're just going to do that. Remember, because the idea is just to kill these denominators here. So we don't necessarily even need the least common denominator. We just need a common denominator. And this is perfectly acceptable to just multiply both of those. So let's go ahead and do that. Okay, so this is the same trick we've used before, right? But the only difference is now instead of a number, we just have an x. So it's x plus h minus 2, where before we just had h plus or minus a number. So it would have been a little simpler before, but this is much better because now we're just going to get the derivative function, and that's the idea here. So let's go ahead and keep going with this. These parentheses, they are necessary, we need them. Got to be careful about that. So this equals the limit as h goes to 0 of what? Distribute this through to the first term, we get 1 over x plus h minus 2 times both of these guys here. So that's times x plus h minus 2 times x minus 2. And then for the second term we have minus 1 over x minus 2 times both of these guys here, x plus h minus 2 and x minus 2. Alright? And now all of that's, all of this whole thing here, I could zoom out a little bit, this whole thing here is being divided by h times x plus h minus 2 times x minus 2. Alright, so kind of a mess algebraically, but that's okay because it's better than finding the derivative, it's better than going through this process 3 times. Alright, so we're just going to do it once, and it's a little bit messier, but that's okay. So here, let's zoom back in kind of. Let's simplify this. 1 over x plus h minus 2, it's going to cancel with the x plus h minus 2. That's wonderful, lovely, fantastic. And then 1 over x minus 2, and then x minus 2. Okay, so now we're left with 1 times x minus 2 minus, remember that's a minus 1 times x plus h minus 2. So remember it's minus this whole quantity here, so we gotta be careful about that and not forget it. So let's go ahead and mosey on back up here. Coming up here, we're going to have equals the limits as h goes to 0 of what? X minus 2 minus x plus h minus 2. X minus 2 minus the quantity x plus h minus 2. And then on the bottom we still just have h times x plus h minus 2 times x minus 2. Right? So you might be tempted to distribute this h or foil this. It's not really foiling, I guess. But you might just be tempted to multiply out the bottom. Just leave it as it is, because remember the idea is to cancel this h eventually. So we just want to leave it separate. We don't want to get it mixed up with any of these guys here. So we just want to get rid of that h. And these two factors here, x plus h minus 2 and x minus 2, just leave them for now, and we'll worry about it when we actually do the limit with direct substitution. So anyway, continuing with this, what's going to happen? Alright, so here x minus 2 minus the quantity x plus h minus 2. Let's drop these parentheses. So in order to do that, we have to distribute the negative sign here. So what's going to happen is we're going to get minus x minus h and then plus 2. So let's go ahead and do that here. So that's minus x minus h and then plus 2. All right, and that is just wonderful. That's fabulous. It's great because now we have x blah 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 minus x. So the x and the minus x, they cancel. Minus 2 and plus 2 are going to cancel. And that's what we want, because the idea is to eventually just have stuff with h in it left over. And now we just have a minus h. So h cancels with this h down here, and then what we're left with is actually minus 1 on the top. Right? We're left with the minus 1 now. So we got to be careful about that. Okay, so this equals, let's just write it over again just so it's easier to see, easier to read. Minus 1 left over on the top, and then on the bottom we have x plus h minus 2 and x minus 2. Alright, now, because we canceled this h over here, now we can do direct substitution. So let's go ahead and do it. And when we do that, we're going to get, oops, actually because we're doing that, we don't need the limit anymore. In fact, we shouldn't have that anymore. So this equals negative 1 over x minus 2 times x minus 2, because we're just going to substitute 0 in for h. So this is negative 1 over x minus 2 times x minus 2. And then we can just rewrite this as negative 1 over x minus 2 quantity squared, like that. And what's this? It's big F prime of x. So that's what this is here. Big F prime of x. Right? And now this is wonderful because now we've gone through this whole messy process only once, and now we have to find the derivative at 3 different points. So we're just going to take those points and plug them into here. And that's much simpler than going through this process multiple times. So we're going to need some more room, so let's go ahead and clear it all. So we just found f prime of x equals negative 1 over the quantity x minus 2 squared. So let's go ahead and make a note of that. So we'll erase this here. So f prime of x we just found is negative 1 over x minus 2 quantity squared. So let's get rid of all that. Probably don't need that room. Okay, so f prime of 0 is negative 1 over 0 minus 2 squared. 0 minus 2 is just negative 2. Negative 2 squared is positive 4. So this is negative 1 over 4. Okay. F prime of 12, that's the next one. F prime of 12, that is negative 1 over 12 minus 2 quantity squared. 12 minus 2 is 10, 10 squared is 100, so this is negative 1 over 100. Alright? Maybe not enough room here. The third one and the last one is f prime to negative 8. So here, f prime to negative 8 is negative 1 over negative 8 minus 2 quantity squared. 1 over negative 8 minus 2 quantity squared. So negative 8 minus 2 is negative 10. negative 10 squared is 100, so this is negative 1 over 100. Right? So same thing as f prime of 12 actually, right? Negative 1 over 100, negative 1 over 100. So that's example 2 with using the derivative function to find the derivative at a point.